Hello friends, welcome to our channel. In previous video we have talked about what will happen when we apply bending moment on a beam for square cross section and circular cross section, mean whichever is safe cross section to use for bending if we apply bending moment. In this video I will talk about shear stress and F is the applied shear force. Means I will explain in this video which cross section is more safe to for application if we are applying shear force, which cross section is more safer, and I am sure you will be amazed to see the result. If you have not watched our previous video, I would recommend please watch it. Now starting our video. Here tau is the shear stress, F is the applied shear force, I is the moment of inertia of the cross section, A is the area, Y is the distance from neutral axis, and A is the area above it. Means whatever we are distance we are taking from the neutral axis, A will be the area above it, and B is the width of the cross section. Now in previous video I haven't explained about neutral axis. Neutral axis is the axis is if we apply the bending moment or shear force, it would neither get affected, means not neither compression nor the tension. Okay, now come to the rectangle. Here is the formula for calculating shear stress in rectangular cross section. I am not going into the depth how this formula has come, because here my concern is to show which cross section is more safe. Okay, so according to the formula, tau is proportional to negative of y square, means negative of distance square, and y varies from 0 at the neutral axis to maximum of value of d by 2. Okay, so if we put d by 2, we would d by 2 square and d by 2 square would get cancelled and we would get 0 shear. Means the shear stress at the extreme is 0, and again if we put y equal to 0 here, then we will get the maximum value of shear stress. Means we can conclude that shear stress is maximum at the neutral axis and minimum towards the outer. Means we would need much more material towards the neutral axis, but lesser material as we move away from the neutral axis. So for circle the formula is like this. If we put y equal to 0 here, we would get maximum value of shear stress, and if we put y equal to r, means radius, we would get shear stress as 0. So in this case also the shear stress is maximum at the neutral axis and 0 at the extreme end. Hence we can clearly conclude that this material, whatever material is put here, is the extra material. We don't need this much amount of material. So using a circular section is more important, is much better, convenient and economical for when we apply shear force. So we can conclude that circular section is more economical and safer if we apply shear force. If you know about torsion, means I want to say about if we are manufacturing a gear and a shaft mounted at a shaft, if we apply a torque at it, it will be the case of pure torsion, means no bending whatsoever is applied on it. So for pure shear, we use a circular cross section of the shaft because a circular section are more safe when we talk about the shear, applying shear force. By applying torque, we are basically applying pure shear, not bending. Hopefully now you have understand why shafts are circular in shape and beams are rectangular in shape, when they are, because they are carrying moment, and shafts are circular because they are carrying torque, and torque result in shear force, and beams, torque result in shear force, and circular section are more economical and safe for shear. Hopefully if you like the video, please subscribe my channel and like it, because your one like and one subscribe will motivate me a lot. Thank you.